Hi and welcome in the fourth episode of Advanced Python tutorial. In this episode, we're going to cover how you can define functions which use an undefined amount of parameters, as well as covering some additional things about generators later in the video, which I have forgot to mention in the first episode. Usually, while creating a function, you would provide the names of the parameters which you want to use in it. For example, you could call them name, age, group, and whatever you really want. But what is it that you should do if you don't know how many variables there will be, or if you just want to allow that function to use an unlimited amount of variables? There are two specific methods which can be used to do so let's get on with the first one. Just to show you that even if you use this method, you can still predefine some parameters, I will add to our function 1 and 2, which will be our two first parameters, just to show that it's still going to work even if you're using it along with the regular parameters. To define our unlimited parameter, we simply have to start with an asterisk and then give it a name, just like a regular parameter. I'm going to call mine other. For the first thing, let's simply try to print out our parameters. Print 1, print 2, and print other. As you can see, when you're referencing your custom parameter, which is actually a list of all the parameters which are going to be passed excessively from the predefined two. So the first one will print our first value, the second one will print our second value, and the third one will actually print a list of all of the remaining values which were also used. We can give it a try by calling our function, and let's just give it some parameters. As you can see, even though our function takes in 3 names, I have actually passed on 10 different parameters, and that is because, like I just said, the first two are going to be assigned to 1 and 2, and then everything after that is going to be converted into a list and assigned to other. So if you would run your script now, you can see that it prints 1, 2, and then an actual list of all of our variables. This list is also iterable, so you could use a for loop. Just like that, we can print out all of our values separately, counting from 1 to 10. And you can also get specific values from it by providing the index of those values inside of a square bracket and trying to print that. As you can see, it prints out 3 because it has an index of 0 as the first value in our list. And everything that you could do to a regular list, you can also do with this one. There is also a second method of passing multiple parameters, and that is using 2 asterisks. However, as you can notice now, all of my parameters which I passed into our function are actually highlighted, and our program is going to crash as soon as we start it. And that is because it actually works slightly different to the previous option with just using a single asterisk. In this case, when you're providing parameters, you actually have to specify the name of each and one of them, because the way they will be passed into your function, they are not going to be organized into a numbered list with an index, but rather assigned to their specific keywords. So we could pass values like third equals 3, fourth equals 4, and so on. And if you can see now, if we started, what you actually get when we're trying to print our other values, we get a dictionary with those values assigned to each other. And just like the previous version worked with everything you can do with lists, this one is going to work the exact same way dictionaries do. And exactly because it works like a dictionary, to access specific values from it, you have to specify the name which is associated with that value rather than an index of it. So if we want to access our 3, we would have to put in quotes, because it's a string, third, which is the name associated to our variable of 3. Another way through which you can access those values is, instead of using the square brackets, you could use .get function and input the name as well, which would work the same way, providing you with 3 in this example. However, what makes using the get function better than the square brackets themselves is that actually when we try to call out a value which doesn't exist, as you can see, it prints out none instead of crashing the program, as if when you would try to input a value into the square brackets which doesn't actually exist, the program would simply crash. So for this reason, it is better to use the get command. So going back to the episode 1 and the topic of generators, there is a couple things I would like to add to that and point out. The first one being the efficiency of generators over regular functions when dealing with large amounts of data. We could demonstrate that by trying to iterate over our generator and printing every value which it gives us. And if I run it, you can see that it prints one value at a time. But what the actual key difference is that if I would use a list instead and simply return that list, for example, doing it this way, if I run the script now, you can see that the exact same thing seemed to happen. However, there is a major difference. And the difference is that our function has to store and then return an actual physical list of items. And that list has to be stored in memory. Meaning, if we would have a list of, let's say, 1,000 or 10,000 values, it would slow down our program significantly and use a lot of memory. However, how generators fix that issue is actually quite simple. Instead of holding on to an entire list and appending to it, they provide you with single values one by one until they go through all of them, but they don't actually keep a physical copy of that entire list, which is exactly why generators are much more efficient than regular functions. And also, exactly because of that functionality of returning a single value at a time rather than an entire list, there is a couple of cool things we can do with them that you couldn't actually do with a regular function. And I will showcase that now by modifying our generator to enter an infinite loop while true, which should never actually end. And I'm going to import module random just so we can get some random values going. And I'm actually going to yield random.randint of between, let's say, 0 and 100. Now you're probably looking at it and wondering how on earth are we going to exit that infinite loop to even get any of those values. And that's where generators come in really useful, because our little for loop over here is actually executed with every yielded value one by one, and not after our generator is fully finished working, which means that everything which we put in our for loop will be executed alongside our generator simultaneously, or not simultaneously, but right after it performs its yield action. So what you can actually do is use an if statement, and we can say if our value yielded from the generator is equal to, let's say, 50, we are going to break. And this break statement over here is actually going to break out our infinite loop from our generator. So the last value which we are going to get yielded from it is going to be 50. And we can check that quickly by printing every value which we go through before actually using our if statement to break out of the loop. And if I start it now, as you can see, it goes through a bunch of different random numbers which were generated in our seemingly infinite loop, and then it finishes on 50, because when value was equal to 50, it executed the break statement which finished our infinite loop. Going further with this, I will now show you the actual order in which things are happening and how it exactly works with the yield statement. So in our generator, I will create a for loop, so that will execute, let's say, 10 times. And first up, it will print a string simply saying pre-yield. Then we will yield our x value. Then we will actually print post-yield, and I can remove all of this. And now we can actually see in which order those three print statements are going to be executed. If we run the file, you can see what happens is that our pre-yield gets executed, sending our message. Then our yield statement returns our x value to our for loop down here, which prints it as 1, and only after our for loop is finished executing, it goes back into the generator and prints our post-yield statement. And that would be everything I think I forgot to mention in the first episode. I hope you're not confused anymore of why you should use generators rather than returning entire lists. And that would be it for today. So yeah.